Every morning, the sun rises without fail. We owe our very lives to its light and warmth. But what exactly is that blazing sphere? Surprisingly, few people really know. Why has the sun burned for 4.6 billion years? Why is the air above its surface hundreds of times hotter than the surface itself? And how could the sun's mood alone bring our civilization to a halt? Today, we'll explore the many mysteries of the sun and the unbreakable bond between the sun and the earth. By the end of this video, tomorrow's sunrise will look completely different. So sit back and enjoy. First, the basics. The sun sits about 150 million kilometers away. Even a bullet train at 300 kilometers per hour would take 57 years to get there. Light makes the trip in 8 minutes and 19 seconds. So the sun you see is always 8 minutes in the past. If the sun vanished this instant, we wouldn't notice for 8 whole minutes. The largest scale prank in the universe, just waiting to happen. The sun is about 1.39 million kilometers across, 109 times wider than Earth. By volume, about 1.3 million Earths would fit inside it. More staggering still is its mass. The sun alone makes up over 99.8% of the entire solar system. Jupiter, Saturn, Earth, all of us, are just the leftover 0.2%. The solar system is, quite literally, the sun's one-man show. By the way, gravity at the sun's surface is about 28 times Earth's. Tough place for a workout. So what is the sun made of? Mostly gas, about 3/4 hydrogen, and almost all the rest helium. There's no solid ground. The visible layer, called the photosphere, is around 6,000 degrees, and the core reaches an unimaginable 15 million degrees, which means you could never land on the sun. You'd just sink in. Well, you'd evaporate long before that. Proof that the sun is a ball of gas with no solid ground shows up in the way it spins. Like Earth, the sun rotates, but astonishingly, different parts spin at different speeds. The equator takes about 25 days for one turn, while near the poles it takes about 35. That's impossible for a solid body. It's a strange rotation only a ball of gas can do. Quiz 1. How long does sunlight take to travel from the sun to the Earth? 1. About 8 seconds. 2. About 8 minutes. Or 3. About 8 hours. The answer is 2. Sunlight takes about 8 minutes to reach us. So you always see the sun as it was 8 minutes ago. Here's a simple question. Why has the sun kept burning for 4.6 billion years? In fact, the sun isn't burning like wood or oil at all. Its energy source is nuclear fusion. In the ultra-hot, ultra-high-pressure core, hydrogen nuclei fuse into helium. In the process, a tiny bit of mass is lost and converted into a colossal amount of energy. Every second, the sun produces about 500,000 times all the energy humanity uses in a year. 4 million tons of mass turn into light and heat every single second. Yet the sun is so vast that it still has about 5 billion years of hydrogen fuel left. Our sun is middle-aged, a star in its prime. Thank you, sun, for not sending us the electricity bill. Curiously, light born in the sun's core can't escape right away. The interior is so densely packed that light bounces off particle after particle, changing direction endlessly. Reaching the surface can take tens of thousands, even hundreds of thousands of years. The sunlight that reached you today may have been born back when humans still use stone tools. The most patient-packed train in the universe. But how did we confirm fusion really happens in the sun's core? The key was the neutrino, a ghost-like particle. Neutrinos born in fusion barely hit anything, escaping the core in just 2 seconds. Japan's Kamiokande detector succeeded in observing these solar neutrinos, in effect peering straight into the sun's core, an achievement that won a Nobel Prize. Now we reach one of the sun's greatest mysteries. The surface is about 6,000 degrees. Yet the corona, the atmosphere above it, exceeds 1 million degrees. It gets hotter as you move away from the heat source, like a campfire that burns hotter the farther you step back. It defies common sense. This is the coronal heating problem, and it has baffled scientists for over half a century. The leading clue is the sun's magnetic field. Countless tiny explosions constantly erupt on the surface, and one theory says they heat the corona above. Another says waves along the magnetic field lines carry the energy. Japan's Hinode satellite has chased this mystery too, but no definitive answer has emerged. So familiar, yet still a star of mysteries. Quiz 2. Which is hotter, the sun's visible surface or the corona, its outer atmosphere? 1. The surface. 2. The corona. Or 3. They are exactly the same. The answer is 2, and it's one of the great mysteries of the sun. The corona is millions of degrees, far hotter than the surface below it. Look at the sun through a telescope, and you may see dark blotches. These are sunspots. They look dark because they're cooler than their surroundings, though even so they're about 4,000 degrees, just dim next to the 6,000 degree surface. Sunspots are where strong magnetic fields break through, blocking the heat rising from below. A bit unfair, really, to call 4,000 degrees cool. Fascinatingly, the number of sunspots rises and falls on an 11-year cycle. This is the sun's activity rhythm. Many spots means an energetic solar maximum, few means a quiet minimum. And in the 17th century, sunspots nearly vanished for 70 years, the Maunder minimum. Records show Europe suffered bitter cold, with rivers freezing over. Look to the edge of the sun, and you may see arches of flame rising up. This is a prominence. Each one is large enough to swallow several Earths. Gas lifted along magnetic field lines builds a vast bridge into space. Some hold their shape for days, while others suddenly collapse and blast off into space. Sometimes the sun shows a terrifying face, the solar flare. It's the largest explosion in the solar system. A major flare can release the energy of 100,000 to 100 million hydrogen bombs in just minutes to hours, and the blast scatters intense radiation and clouds of charged gas across space. In 1859, the largest solar storm ever recorded struck Earth, the Carrington event. Skies worldwide blazed red with auroras, telegraph machines threw sparks, and networks went down. If a storm that size hit today, power grids would be destroyed, blackouts could last months, and GPS and communication satellites would fail. Some estimates put the damage in the trillions. In fact, in 1989, a solar storm caused a 9-hour blackout in Quebec, Canada, affecting 6 million people. The sun is near its activity maximum around 2025, and space agencies worldwide keep constant watch. As the term space weather forecast suggests, reading the sun's mood has become a matter of survival for modern civilization. Even without explosions, the sun constantly streams out charged particles. This is the solar wind, racing at 400 to 800 kilometers per second. It blows against Earth nonstop. So why are we safe? The answer is Earth's invisible shield, its magnetic field. 800 kilometers a second, by the way, is Tokyo to Osaka in under a second. Sorry, bullet train. Earth's magnetic field works like a shield, deflecting most of the harmful particles back into space. And particles that slip through the gaps collide with the atmosphere over the poles and glow. That's the aurora. Those magical curtains of light are actually the glow of a battle between Earth's shield and the solar wind. Mars shows us the fate of a world without a magnetic field. Ancient Mars is thought to have had a thick atmosphere and oceans. But once it lost its magnetic field, the solar wind stripped its air away over billions of years, leaving the barren desert we see today. Earth's magnetic field is, quite literally, a lifeline, an invisible guardian. Now, the Sun and life. The biggest reason Earth can host life is that its distance from the Sun is just right. A little closer, and the oceans would boil away. A little farther, and everything would freeze. This just right band where liquid water can exist is called the habitable zone. Earth has circled this miraculous spot for 4.6 billion years. And sunlight feeds life on Earth directly. Through photosynthesis, plants turn sunlight into nutrients and breathe out oxygen. Everything we eat and the oxygen we breathe traces back to the sun's energy. The energy moving your body right now is a fragment of sunlight that traveled 8 minutes and 19 seconds across space. The sun even governs our body's rhythms. Morning light resets our internal clock, and at night we naturally grow sleepy. Sunlight on our skin makes vitamin D, strengthening our bones. For millions of years, humans have woken with the sun and slept with the sun. The sun is the rhythm of life, etched deep into our bodies. Even a red sunset is a collaboration between the sun and Earth. Sunlight is a mix of many colors, but blue light scatters easily off air molecules, which is why the daytime sky is blue. At dusk, light travels a long path through the atmosphere, so the blue is scattered away and only red reaches your eyes. That crimson glow is proof the light journeyed through our air. Though, narrating this on a sunset date tends to kill the mood. Use with care. Now, the sun and the moon share a miraculous coincidence. The sun is about 400 times wider than the moon, and it also sits about 400 times farther away. So in our sky, the two appear almost exactly the same size. Thanks to this, the moon can perfectly cover the sun in a total eclipse. So perfect you'd suspect the universe hired a stage director. At the moment of totality, the daytime sky suddenly darkens like night, and a pearly corona appears around the sun. It's the only chance to see the corona, normally hidden by the sun's glare, with the naked eye. In fact, the discovery that the corona is 1,000,000 degrees came from eclipse observations. An eclipse isn't just beautiful, it's a grand event that opened the doors of solar science. Humans have watched the sun since ancient times. In the 17th century, Galileo recorded sunspots through his telescope and realized the sun rotates. Today, satellites watch the sun around the clock. NASA's Solar Dynamics Observatory films it in high resolution, and Japan's Hinode observes its magnetic field with precision. Then in 2021, a milestone in human history, NASA's Parker Solar Probe became the first craft to fly through the sun's corona. In a sense, humanity touched the sun for the first time. Shielded against heat beyond 1,000 degrees, Parker keeps making its closest approaches, closing in on the secrets of coronal heating and the origin of the solar wind. Advancing technology has revealed the sun's hidden face too. The sun is constantly ringing, like a bell. Its surface oscillates up and down over minutes, and by analyzing this, we can probe the sun's interior we can never see directly. It's the same idea as using earthquakes to study Earth's insides, and it's called helioseismology, listening to the sun's heartbeat to see inside it. Before the sun's future, one grand fact: the sun isn't standing still. Towing all the planets along, it races through the galaxy at about 220 kilometers per second. One lap of the galaxy takes about 200 million years. Since its birth, the sun has made only about 20 laps. Right now, we're all traveling through the galaxy with the sun. Just sitting there, you're moving at 800,000 kilometers per hour. Safe travels. So will the sun ever end? Yes. About 5 billion years from now, having used up its hydrogen, the sun will swell enormously into a red giant, over 100 times its current size. Mercury and Venus will be swallowed, and Earth will either be scorched or consumed. Then again, that's 5 billion years away. It won't affect your plans this week, so relax. The swollen sun will eventually cast off its outer gas into space, leaving a beautiful ring of light. And at the center, a small ember shrunk to the size of Earth remains, a white dwarf. It will cool slowly over tens of billions of years. But don't worry, that's 5 billion years away. The sun's life is only at its halfway point. Quiz 3. How will our sun end its life about 5 billion years from now? 1. It explodes as a supernova. 2. It swells into a red giant, then fades into a white dwarf. Or 3. It collapses into a black hole. The answer is 2. The sun isn't heavy enough to explode or form a black hole. It will swell into a red giant, then gently fade into a small white dwarf. So how was it? Turning 4 million tons of itself into light every second, the sun has shone without rest for 4.6 billion years. That light grows our plants, warms our seas, and feeds all life on Earth. Even while holding mysteries we still can't solve, like the corona, the sun shines on us today, unchanged. Tomorrow morning, when the sun rises, take a moment to remember. That light left the sun 8 minutes and 19 seconds ago and traveled 150 million kilometers to reach you. If you enjoyed this video, a like and a subscribe would mean a lot. Thank you so much for watching to the end.